Hey, in this video we're going to make a torus out of voxels or cubes like you see here. And we're going to do this like the earlier videos where we just make first make a cube of cubes, and then we just decide if we actually want to make a cube at each position. So it's kind of like this, where you have a block, and inside that block is the thing we actually want, and then we're deciding not to make the stuff on the outside. So I got set up in the earlier videos, but in the video description, you just need VoxelTools, the script, and also an assets, a resources folder with a capital R, and a cube in there, and then you're ready to go. So in scripts, right click, create, C# script, call it Voxel Torus, and open that up. So first to start, we're going to make a cube. And the size of the cube is going to be fill size. Well, that's actually half a length, but whatever. And we're going to, like before, make our loop. So we're going to start at negative fill size. We're going to keep going as long as I is less than positive fill size. And we're going to increase by 1. And I'm going to copy that and do it 3 times inside. And have a look at the earlier videos if you want to. Whoops, that's an L. It should be a K. IJK, vector stuff. And on this last loop, we're going to open up a bracket and close. So everything here is going to happen in this loop. And what we could do is VoxelTools.make_cube IJK. And this is going to make a 60 by 60 by 60 cube of cubes. But here we want to do an if statement, if something, we want to make a cube or not. So here's our cube of cubes, and then inside somewhere, we might have this cube, and we got to decide, should we make this actually? Well, no, because it's not in the torus. This one, though, we do want to make that cube. So we have to decide that somehow. And here's how we're going to do it. So this cube is at IJK. What we're going to do is we're going to get the vector, of that cube. We're going to turn it into a unit vector, because right now the length of this could be 5, it could be 20, whatever, I don't know. We want to turn it into a tiny little unit vector. It has the same direction, but the length is 1. And then we're going to multiply this by the length of the donut. So once we have this red one, we can multiply it by this length here, and it'll be an arrow like this. And it's specifically pointing right to the center of the donut like that. So basically this is a way, given some cube, say we've got now a cube over here, I want to get this point right here. And we're going to see if it's close to that point. And if it is, we're going to make it. If it's too far, we're not. So this cube over here, we're going to, one more time, we're going to have this vector arrow. We're going to find its unit direction, so it's length 1 arrow, in the same direction, but length 1. And then I'm going to multiply it by this length. And that's going to turn it into this, which is that point that we need to compare the cube to. So we need some constants. First, there's going to be that inner radius. So the inner radius I'm going to have is going to be this length right here. So if this is this is the actual donut. And then this is going to be that inner radius. So let's just say float inner radius is going to be 8. We also need a thickness of the donut. And that's going to be this thickness here. Or actually here, we'll go with this. So it's like the radius of a circle. So these little circles inside the donut you can kind of see, right? So let's say we have this one here. The thickness is that radius. Float thickness equals 3. So first, the cube position, this one's easy. That's just IJK, like we have in the picture. Oh wait, cube position equals new vector 3. There we go. So that's the cube position. Next, the cube direction is going to be that unit vector. Okay, so cube direction. So this is going to be almost this ijk vector, but actually we don't care about j. I'm going to make j 0. I'm going to make j 0 because if you can imagine this disk is our donut, this is j, and that just doesn't matter to me, okay? Because j could be all the way up here. That's the y of Unity, and I don't actually care. It's not going to change the direction on this donut. It's not going to change that direction. If this cube is popping out of your computer screen towards you a lot, doesn't matter. That arrow is just still going to be the same. So I'm going to set j to 0. It's going to be I0k. So new vector 3, we're going to use cube positions x, 0 for the y, or the j, cube position z. Okay, but this isn't a unit vector, right? It's flattened, that's 0, but we're actually going to say cube direction dot normalize, and that's what turning it into a length 1 line means. So now this is going to be length 1 and pointing the same way, so cube direction is now this red arrow right here. Man, that was a crazy scribble. Length 1 vector in the same direction, that's cube direction. And now we want to get this green one. We're going to call that donut center, because it's the center of the donut this time anyway. It's going to keep changing depending on the cube. But so donut center is going to be the length 1 vector, that direction, times, well, times what? What's the length that this should be? This green thing. So if we've got the inner radius as this, and this is the thickness, well, it looks like that's inner radius plus thickness. That's the length of this green one. So the direction times inner radius plus thickness. So now we've got the center, and we've got our cube position, and all we got to do is check, is the cube position too far from the center? Then we don't want to make it, but if it's good, then we do. So if vector 3 dot distance between two vectors, we're going to give it the cube position, and we're going to give it the donut center, is what? Is less than what? Thickness. So if it's within that thickness, I'm going to save this, and this is close to what we need, but it's not quite. And again, the Voxel Torus script is just a text file on our computer, so I'm going to get rid of this crap. So click on something here, maybe ground, add component, Voxel Torus, and we're going to see what we have. Hey, alright, that's pretty good. I think it's going through the floor. I'm going to make this a little higher to see what's up. And so instead of j, let's just say j plus 5. So everyone will be 5 higher. Okay, that's great. There's a center thing for some reason, but that's a good looking torus. Okay, made out of cubes. Now this center is a little bit of a fringe case. One last thing we've got to watch out for. So look at how we calculated this. If, let's say I and k are 0, that's what the center was looking like, right? Because we're ignoring j, so these coordinates are I and k. If that's 0, so it's 0, 0, 0. Normalize, okay, well it's 0, 0, 0. There's no direction. So 0 times 0 is 0. Donut center is always 0. So that's not right. Looks like we calculated this center. These center points are never 0, 0, 0. But hey, well it is today. So we got to make a little exception. If I is 0 and k is 0, then we're just going to quit this little run. Continue. Spelling. So what this continue means is, normally these for loops, so this will happen, right? It's going to do this one at a time. But actually when it gets here, if it continues, it's going to skip this code. It's just going to say, oh, continue. Okay, it's going to jump back up here, do the next one, and ignore this one little case. So here we go. Now we save it. All right, there's our torus. Nice. Now one extra thing you may want to look into doing is a size. So let's say I want to make it 20% or even 10%, all the like tiny little cubes, okay? All you got to do is multiply these by size. Oh, plus 5 times size times size. I need to make the cube smaller. And in make cube, you can do that. Just do a comma for more arguments. Oh, color. Let's change it to yellow. And size is size. So there you go. Ooh, I fell through the floor again. Yeah, because we're starting in the same place. Outrageous. So how about we just do j times size plus 5. It was 10% of 5 as well. I wasn't thinking. Cool, so there's a torus, and I'm going to press Q to make them drop, and it's going to kill my computer. Hey, I didn't do anything. Oh, I didn't. Yeah, that was my previous videos. I had an extra little line here, spheroid. I gotta add this right here. So every frame we're going to check. So 60 times a second. Are we pressing Q? If we are, make all cubes fall. That's a thing I made. You can look at if you want, but that was such a disappointing finale. Okay. Now it's going to make my computer slow. There we go. Oh, well, I can make a good point too. So this fell through the floor. Have you ever noticed that happen to you? So what's happening here is it's checking every now and then if it's going to fall through this. And if it hits this barrier, it's going to stop and say, oh man, I hit something, and explode. But my computer's a bit slow and Unity physics aren't perfect. So it checked here. Nope, didn't hit the ground. Checked here, didn't hit it. Didn't hit it. Nope, didn't hit it. Nope. Because it never actually... it wasn't smooth enough to hit that. They're also small cubes. They're tiny cubes. So that adds to it. So I'm going to do a little trick. It's a little hard for Unity to do collisions with my floor because it's a mesh. There's a lot of different polygons, okay, going on here. And it's hard for Unity to constantly check all the time. Are we hitting the floor? Are we hitting the floor? Are we hitting the floor? So I'm just going to add a big cube underneath. And Unity has a much easier time with that. The floor is flat anyway, so create a cube. Let's put it at 0, 0, 0. I'm going to make it 60 by 60 by 60. And at negative 30, whoops, that's a rotation, negative 30. Okay, but that's exactly, you can see, it's fighting with the floor. Those faces are in the exact same position. That's no good. I'm going to make it negative 30.001. There you go. So now, just a little bit lower. And that collision is going to work because it's not a mesh collider, it's a box collider. That's a lot easier for Unity to work with. Nice and slow. Boom. Well, run this on a better computer. Or you know what? Here we go. I'm going to make it a 2 and a 6. A 7, a 6. It's a smaller torus and it won't be so crazy slow. It's still pretty slow. But that's how you make a torus out of cubes in Unity.